Okay, let's get started. Today's topic, AI-based analytics in the cloud. So I'm going to really combine a couple topics around uh, big data and AI, bringing them together and talking about how you can allow your data analysts access to all of the amazing technology that the cloud offers you, but putting it in their hands in the line of business applications. Okay, so first, this is nothing new, but just to reiterate how there's this AI skills shortage, right? It's still happening. So I just pointed out a couple takeaways from some recent reports. One from a CIO report saying that data science is one of the most difficult roles to fill. And from another report that said that more companies would do AI projects if they had the technical expertise to do them. So it's still an issue. And what we're going to talk about today hopefully addresses some of the concern there. So we're going to talk about spreadsheets. We're going to talk about how do you bring AI to the many users of the most common business application where we have all kinds of data, financial data, operational data in spreadsheets, and you want to unlock more insights with that data. So we'll look into how to do that. So how does data make its way into spreadsheets? There can be a lot of different ways. I just point out a few. One could be you're generating a report and exporting it as CSV, Excel, you name it, and you have access to data that's in some kind of a business system. You could run a custom query. You could use an API. There might be some other ways. You end up with this data like we see here in a sheet. But what's an issue with doing things this way, working with that data? First is data freshness. The data from the extract is a one-time thing. So what if there are corrections in the source system, new data? You don't have that. Number two, the size of the data. So when you think about big data, spreadsheets aren't usually the first thing that you think of, right? So they're certainly capable of handling more and more data, but there are definitely some constraints around it. Anything else? Well, another important consideration is security, where let's say on the left side you have access to data that's only certain users or groups are authorized to access that data. You perform an extract, and then after that, it's really out of any sort of controls. User could email a report to another group if there could be sensitive data in it. So you sort of lost that management around authorization. So connected sheets is a solution from Google that combines both of these concepts together, sort of the best of both worlds, where you can work from sheets, so it's easy to use, a familiar interface, and you can use BigQuery, our enterprise data warehouse, to manage petabytes of data and across all different kinds of tables, and combining those together and addressing some of those issues that we just discussed. Let's do a quick demo. So throughout this presentation, I want to show a couple, snapshots of the products and concepts to make it a little more concrete. So the data set I'm going to use is from actually the state of Iowa liquor sales. So this is wholesale purchases that the state of Iowa records. It's been about 10 years now. This is one of many data sets that is in our set of public data sets. It's a good example in that it kind of translates to a lot of retail type of scenarios. So this is the data set. What I'm going to do now is show sheets where I've connected to this data set that's stored in BigQuery. And so this is Google Sheets. And what you're seeing here in this tab is a connected sheet. I've already done the connection just to briefly show that. You go to data connectors, you connect to BigQuery, select your table, and here we are. And you see there's 21 million rows that we're working with. And you have the ability here to refresh the data, as well as you have some options around potentially even scheduling refresh and things like that. So it's like you're working with a spreadsheet, but the data can be dynamic. So let's just show a couple quick capabilities here. You can perform an extract if you want to work with some of the rows. You can do your standard charts, pivot tables. I've created a couple of those already. So here I did an extract of some of the purchases. So literally each of these rows is a wholesale purchase. It shows, here we have the name of the store, the bottles sold, this dollars, etc., and the date and the type of liquor that it was. So I just pulled these 5 columns you see here on the right side. You can apply filters, and there you are. Now let's look at a chart. So this is showing the dollars sold over time. And so, if we go here and we drill into this a little bit, you can update the data range and all that. Here we're seeing this sort of seasonal pattern, right? It's up and to the right, of course, and it's kind of repeating yearly. And then on our pivot table here, here's an example of applying some big data analysis here in our spreadsheet. So all I simply did here was I created a pivot table where each row was an item, and we had a sum of the sale amount here, and I basically took the top 10. So it was a way to say, what are the top 10 most popular liquors in terms of sales in this data set? So we got our answer. Pretty cool. So that's sort of connected sheets in a quick demo. So let's talk now more about BigQuery, which is powering this solution that you just saw. So BigQuery is Google's enterprise data warehouse for analytics. You can use standard SQL. It's serverless, very scalable, secure, and it's running on top of some technologies that have been in Google for years to support very high scale storage and compute. And it has a number of different client libraries to easily access it, REST APIs, a web interface that we're going to see shortly, command line, etc. So lots of different ways to utilize BigQuery. BigQuery has a feature called BigQuery Machine Learning, or BigQuery ML, that allows you to train and deploy very robust machine learning models with SQL-like syntax here. So you can build models, and you'll see the wide variety of different model types, deploy those models, forecast with them, etc., all with BigQuery ML. Here are the current set of supported model types, and you see them in different categories here. Classification being the ability to put data into buckets. Is this a fraudulent transaction? Yes or no. Regression giving us a number. Like what is the estimated price based on some characteristics. And you see a number of other model types as well. And we can even import TensorFlow models or do some model import export. What I want to show today is actually time series forecasting that's built into BigQuery ML. All right, so we won't go too deep into BigQuery, but I just wanted to show the interface so that it's, again, a little more concrete. So this is the BigQuery web user interface. You've got sort of a list of tables here. I'm going to that Iowa liquor sales table, and you see below, I'll zoom in a little bit, the schema where you see each of the individual columns that are in the table. Some details. Sometimes people can add metadata about the table. A preview of some rows. So we're seeing the address of the store that ordered the liquor, the name, all the different other characteristics, sale dollars, etc. All here, and you can easily run queries. So I'll just go here. Let's query the table. Select star from here. And it'll run the query, and I'll get the results back here in the web UI. And then, maybe you want to then, save your results. You have a bunch of different places you can do that. So that's super quick version of BigQuery, but just to give you a picture of that. So let's go back to the presentation. We've now talked about sheets and BigQuery and connecting the two. Let's now look at a case study around demand forecasting. So demand forecasting allows you to solve some of the problems like you see here. It's like in transportation, predicting ticket sales, maybe in media or gaming where you're looking at views as specific content or games, that kind of thing. Telecom, maybe network traffic. And these are just a few. There are just so many examples of this concept of trying to figure out how much of a service or good is going to be consumed. And we'll look at retail. That's a pretty easy one to wrap our heads around. And in retail, the problem is well studied, and in business, this idea of your supply varies, and if you don't predict properly on either side, you're going to not optimize your profit, right? If you don't have enough supply, you're going to run out of stock. If you have too much, items are going to sit on the shelf, and there's issues there. So you really want to try to forecast as well as possible, and there's a lot of solutions out there that are aimed at addressing these kind of problems. So let's look at this data and see how BigQuery ML could help us do some prediction with it. So we've got our transactional data. Remember, we ran the query in BigQuery, and if you recall, each individual line item is a purchase of liquor, number of bottles, the sale amount, and the type of liquor. So to train a model, what we might do is something like this. So I'll break down this select statement here. So we're selecting a few columns from the database, the date of the purchase, the item, and how many bottles were sold. And we're grouping that by both the day and the item, right? And we're looking within a certain date range. And that's what you see here on the left side is, day by day for Black Velvet, but you're going to also see some similar rows for other types of liquor. And if you were to graph that, it would look something like this. We're just taking a small slice of the data, right? So this was for a year. You can again see some seasonality here where it looks like in January, at the beginning of the year, there's a bit of a spike, but we don't have multiple years, so can't really say too much. But yeah, so we're basically computing that for different types of liquor over time. So now we've got our training data. Remember, our training data is, let's just back up a second. This is where the ML model learns from. This is where we're looking at patterns and trends from. So now we're going to actually create the model. So here's what the syntax looks like for creating a model. You see on the left side some of the different capabilities. You're going to see this as called an ARIMA model type, and if you're familiar with forecasting, that's a very popular statistical method, but it does a lot more than that. There's a lot of data pre-processing. There's ability to add holidays for those kind of effects for all different kinds of regions. There's ability to clean up the data if there's some outliers, handling that. It does automatic selection of some of the parameters to find the optimal ARIMA model. So it really takes a lot of complex forecasting capability and just makes it a few lines of code here. So let's just walk through briefly what these line items are. So we're creating a model called forecast by product within the IO liquor data set. The data set is kind of like a container for different tables and models and things like that. The next part, we specify the options, and here's where you say what kind of model is it? Is it a deep neural network? Is it a ARIMA, et cetera? If it's an ARIMA model, you have a few parameters. We're not showing all of them here, but here are the few important ones. The timestamp column, right? That's the time, the date we're referring to here. The data column, this is the item that we're trying to predict. That's the total amount sold. And then the ID column, and that's optional. This is if you happen to have multiple stores, multiple SKUs of a product, it can actually create multiple models in parallel for each of those different IDs. If your data doesn't have that sort of notion of multiple items, you don't have to have an ID. Okay, so we specified the model options. And then the next part is just saying, what are we going to train on? And we're simply selecting each of those 3 columns that I specified in that training data. And then we execute our query and it's going to build the model. Okay, so it usually is pretty quick. I mean, it depends, of course, on your the amount of data you're training with. So say we've built our model. How do we use that model and how do we forecast with it? There's an ml.forecast syntax here. And what we're doing here, we just say select star. And I'm not showing the results here, but you're going to get things like the forecasted value, the forecasted date. You're also going to have a confidence interval. So you're seeing here in our query that we're specifying we're going to forecast 30 days out, and we're going to have a confidence interval of 90%. So it'll give us a low and high range around that forecast interval. And you can see that in the chart. So here we've forecasted 30 days out, and you see the shaded area being the confidence interval, and the actual being in green, the forecast being in orange, and it tracks pretty close to that. And that's the forecast that we got out of this function. Okay, and if you want to find out more about that use case, there's a great article on that goes into what we discussed in more detail. And you can also find a YouTube video which summarizes it as well. So that is how you can use BigQuery ML to build some really interesting forecasting models. So now let's talk about building your own AI solution. So let's look at combining some of these technologies we just discussed for maybe that problem, maybe a different problem. So let's look at what your solution requirements might be. So if there's a typical enterprise use case where you need to build a custom machine learning model and share that with people throughout your organization, there are a few technologies we could look at combining together. And remember, we talked about using Sheets as a way that data analysts or business users can get easy access to those machine learning models. And we were talking about BigQuery ML, and connected Sheets. Let's talk about one more technology I haven't mentioned yet called AppScript. And AppScript is simply a scripting language that automates tasks across Google products and services. You might think of it sort of as a macro language, but it's really full-fledged JavaScript that allows you to connect to Google Cloud Services or Google Workspace services like Docs, Sheets, etc. And so the workflow really is going to be where we have Sheets, BigQuery, and AppScript being the glue between these technologies to take data that's in the spreadsheet, and we want to train our model, right? So we somehow need to get the data into BigQuery. What we're going to do with AppScript is take the selected range of data for training and put that into a temporary table in BigQuery, train with that, and then we can forecast. We get a result coming back from BigQuery, and then using AppScript, we can take that result and we can populate a range of cells back in our spreadsheet. So AppScript is the go-between these two technologies. And so let's look at a demo of that. So the example I'm going to show you is a sample that's in our ML integration samples repo. And it walks through how to, you see all the code here in this repo and an explanation of how you install it. This example is also in a blog post where you'll see a very detailed explanation of all of this. And then at the bottom, I just wanted to point out that there is a couple links to the code sample that I just point out, as well as a sheet that's pre-installed with the code sample. So it'll allow you to try it out yourself without going to the GitHub repo and all that. So let's go to that sheet. Let's take a look at how we'd use this sample. And the idea here is that you would potentially need to modify this if your data is in a different format or something like that, but how it could be done with spreadsheets in your organization. So when you open up the sheet, you'll see some information about how to get started. Let's walk through some example data. So this data set is from Google Analytics. This is another public data set that you can have access to. And this just has an example of hourly visits to a website. And I don't recall exactly how the time interval, but I believe it's something like 7,000 different data points, right? So that's our training data. That's what we're going to learn from. We're going to be able to forecast the future based on that. So let's take a look at how AppScript works and how that sort of combines sheets and BigQuery. So I've created this custom menu item with AppScript here called BigQuery ML, and you see that you can train your model, you can forecast with it, and then I added a couple configuration options if you want to set your Google Cloud project, etc., right there. So let's just kind of look at how you'd use something like this. So I'm just going to take some of our data here and put it over here to the side. And with this, I want to train. I want to learn the trend from this data. Now, just because this is a quick demo, I want it to train quickly. I'm only training on a few data points. I would really recommend training on the whole data set, but let's look at a very small amount of data just to walk through the process. So I'd say train here. It's going to run the script. So again, it's going to take this data that's in the spreadsheet, it's going to copy it into a temporary table in BigQuery, and it's going to build a new model, behind the scenes. And then we have a model that's already trained. So it finished training already, again, with the small data set. So I have a custom model that is trained specifically for my data. And then how do I use that? I can forecast. I could say, well, let's see, if I want to forecast 3 time periods forward, I could just select those cells and say BigQuery forecast. It'll run the script, and there we are. We see our forecast after that. So that's all that you need to do as a user. Let's look at how the add-on works. So I would go to Tools, and then to my script editor. And this is where the code is to run that sample. I won't get into all the coding details here, but just wanted to show you kind of what's happening in AppScript, right? So I had a little bit of a section here to set up my user interface where I defined each of the different menu items. And each of these items then is linked to a function, my training function, my forecast function. And like training, for instance, what it's doing is it's grabbing those cells that are selected, and then it's creating one of those, dynamically creating one of those statements that we saw here in the example to create a model. So it's just pointing to that data in the temporary table that I created from passing that data to BigQuery. Okay, so that is what's happening behind the scenes. I actually created a model with this whole data set, and I wanted to see how it worked. This wasn't cherry picked data or anything like that. I literally took this data set and I took trained up to the last 3 days of data so that we could see how well it did. So what you're seeing is the last week for context, and then I'm predicting 3 days out. You see red is where it predicted, and blue was the actual. So just at eyeballing this, looks like it really captured those trends well. And so yeah, this is the kind of capability that you get by leveraging the forecasting within Sheets. So let's wrap it up. If you want to find out more about what I discussed today, you can find the article in the Google Cloud blog. I created a short link here, bit.ly/ml-sheet. So you can visit the blog post article, and it has links to the code sample and the demo spreadsheet we talked about today.